Good morning, scholars. Welcome back to the channel. This morning we're looking at the geometric sequence. So we did a video on the arithmetic sequence. Now we're looking at the geometric sequence. What is the geometric sequence? Let's look at the definition. In a geometric sequence, a set of terms or numbers obey a particular pattern or law. They increase or decrease by a common ratio, using division or multiplication. Let me read that again. In a geometric sequence, a set of terms or numbers obey a particular pattern or law. They increase or decrease by a common ratio, using division or multiplication. When we did the arithmetic sequence, we said that the numbers or terms obeyed a pattern according to a common difference. So we were either adding something to each of the terms or subtracting something to each of the terms, basically, right? Sometimes they twist it up and we added something to also to the difference. But basically speaking, in the arithmetic sequence, we're either adding the same thing or subtracting the same thing from the terms. And that was called a common difference. In the geometric sequence now, we have a common ratio. So whereas in arithmetic sequence we focus on addition and subtraction, in the geometric sequence we're focusing on multiplication or division. So the numbers are increasing or decreasing because we are multiplying them by a common ratio or dividing them by a common ratio. Of course, just like what they did to us in the arithmetic sequence, they can kind of twist things up and just to challenge us. But basically speaking, we're either going to be multiplying the terms by something each time or dividing the term by something each time, depending on whether the sequence is ascending or descending. So all we really need to do is to figure out what is the common ratio and then apply that to the next terms to get the missing terms. So we're going to do that. It says complete the geometric sequences. Most of them, the numbers at the end are missing. So once we figure out the pattern, we just continue that pattern to get the ones at the end. In some cases, the numbers are in the middle, right? So we're going to figure out the pattern. All right, now I like to write at the top or in between the terms what's happening, what is the pattern, so that I can just go ahead and apply that to the next terms. So from 3 to 6, we are multiplying by 2. 3, 2 is 6. All right, and 3 to 9. So 3 times 2 gives 6. 3 times 3 gives 9. 3 times 4 gives 12, and so on. So basically then, this is like we're saying the 3 times table. 3, 2 is 6. 3, 3 is 9. 3, 4 is 12. So the next in the series then will be 3 5s, which will be 15, and then 3 6s, which will be 18. So basically we're multiplying the first term by different ratios. So 3 2s, 3 3s, 3 4s, 3 5s, 3 6s. All right, now from 4 to 8 to 24. All right, so let's see if we're just using the 4 like what happened with the 3. So 4 2s would give 8, but 4 3s does not give 24, right? So clearly, they're not adding anything either, so we know it's not an arithmetic sequence. It's a geometric sequence. The numbers are getting progressively bigger. But it's not like we're saying, it's not like the 4 times table like what happened with the 3. Something else is happening. Alright, so this is 4 twos. So 4 twos give 8. From 8 to 24, we'll have to multiply by 3. So 4 twos 8. 8 threes 24. Alright, so it seems as if the sequence is progressing. For each term, we're going to multiply it by, we're going to add 1 to the ratio. So this would be 24 times 4, and then this term will be times 5. Okay, so 4 twos give 8. 8 threes give 24. So now it will be 24 times 4. 4 4 is 16, 4 2 is 8 and 1 9, and then 96 times 5. So 5 6 is 30, 5 9 is 45 plus 3 48. So the numbers are progressively getting bigger, exponentially getting bigger. Alright, so 1 to 1. So we multiply by 1. 1 times 1 gives 1. 1 times 2 gives 2. 2 times 3 gives 6. Alright, so multiply by 1, multiply by 2, multiply by 3. So now it will be 6 times 4, and that number times 5. So 6 4 is 24, and 24 times 5, 4 5 is 20, so that will be 70. So each term we keep multiplying progressively by 1 more. We add 1 to the common ratio each time. Or 8, 8 to 16. So this seems like we're ending with 40. We know 8 can go into 40. This seems like we just keep multiplying the first term progressively. So this is 8 2 16, 8 3 is 24, 8 4 is 32, and 8 5s would give 40. So this is the 8 times table, similar to the 3 times table that we had here. 8 1 is 8, 8 2 is 16, 8 3 is 24, 8 4 is 32, 8 5 is 40. Alright, now what are we doing here? 14 times 2 give 28. 14 times 3 give 42. So now let's do 14 times 4. Alright, so 14 2 is 28, 14 3 is 4 4 is 16, 4 1 is 4 and 1 5. And then 14 times 5, 5 4 is 20, 5 1 is 5 and 2. So that's 70. So this is a 14 times table. Alright, here we're progressing by, so let's see, 2, 4, 6. So this looks like 2 times table, right? 2, 4, 6. They all have x. 2, 4, 6. So the next one will be 8. And the next one will be 10. 2, 4, 6, 8, 10. Alright, so we have P, then something is missing, then 10P, something is missing, 20P. Alright, so we have 1P. Between 1P and 10P, since our term is missing, so 1 and 10, so we need to divide that 10 by 2 since our term is missing. That will give us 5. And the 10 and 20 divided by 2, that will give us 5. So we need to add 5 then. So this will be 5P and 15P. So we have 1, 5, 10, 15, 20. So that's your 5 times table. 5 1 is 5. 5 2 is 10. 5 3 is 15. 5 4 is 20. So these were advancing, these were ascending. So now let's look at some that are descending. And you can just look, because you should know your times tables. So you can just look at the numbers and see if they fit any of the timetables, right? So looking at this, I'm seeing the 3 times table. So we have 3 7s 21, 3 6s 18, 3 5s 15. So now we need 3 4s 12 and 3 3s, which is 9 because it's descending, getting less. 50, 40, 30. That's the 10 times table. 10 5s 50, 10 4s 40, 10 3s 30. So now we need 10 2s 20, 10 1s 10. 500, 250, 125. So it seems to me they keep dividing each term by 2. If we divide 500 by 2, we get 250. If we divide 250 by 2, we get 125. So we're dividing by 2. So we need to divide 125 by 2. 2 into 12, 6. 2 into 5, 2. Remainder 1. So we can write that 0.5. 62 divided by 2. 2 into 6, 3, 2 into 2, 1, 2 into 5, 2, and 2 into 10, 5. Yes? What is it, Tari?
Tari, come here.
Alright, so number 11, if we look at the terms, we're seeing the 11 times table. 11 8 88, 11 7 77, and all the numbers there are fitting.
Hello? No, you're
Okay, sorry about that, guys. So this is the 11 times table. 11 8 88, 11 7 77. So it should be 11 6s 66, 11 5s 55, and 11 4s 44. Or what are they doing at number 12? From 1/16 to 1/8 to a quarter, they're actually multiplying by 2. They're multiplying, if we multiply 1/16 by 2, we get 1/8. Multiply 1/8 by 2, we get a quarter. And if we multiply a quarter by 2, we get a half. And a half times 2, we get 1. Alright, here we're starting with 7, so that's an indication. It might be the 7 times table, so let's check. We know this is 7 1s, this is 7 4s, 7 5s. So then what's missing between the 1 and the 4? It will be 7 2s and 7 3s. So 7 2s will be 14, 7 3s 21. So 7 1s, 7 2s, 7 3s, 7 4s, 7 5. And finally 0.1, 0.01, 0.001. So we're dividing by 10 each time. The decimals keep getting smaller by powers of 10. So this should be then 0.0001 if we divide it by 10, and it should be 0.00001. The common ratio is 10. We're dividing each term by 10 each time. Alright, so for the geometric sequence, we're either dividing or multiplying the terms by a common ratio. So many times the terms are following a particular timetable, right? Because if we keep multiplying by the same common ratio, you're basically saying the timetables for that ratio. And it could be advancing or it could be decreasing. Could be ascending or descending. So if you can pick up which timetable they're following, then that would be a good clue. As well as check to see, are they halving the number each time? Did they start multiplying by a common ratio and then they're doing something to the ratio itself each time, right? So maybe they start multiplying by 1, then they multiply by 2, then they multiply that by 3, then that by 4. So sometimes each time you get a new term, that term is being multiplied by the ratio added to something. So these are more complicated patterns, so you have to look carefully. If it's not exactly going up by a times table, then it could mean each term they are doing something to the common ratio each time. Alright, so just look carefully at those and you'll be able to figure out the pattern and then complete the sequences. So if you have benefited from this video, just drop a line to say thank you, miss, and also share the video so other persons can benefit from the video. Alright, so I'll see you in the next video. Take care.